Thank you for joining us today for the topic of automated SPE method development for the research laboratory. My name is Tony Hoffine, Global Smart Prep Market Development Manager for Horizon Technology. SPE method development presents some unique challenges to the scientist. We often have one sample extract that we'd like to develop for a multiple group of compounds. It's challenging because added to that we have lower LOQ and LOD levels to consider. When developing SPE methods, the manual process can be quite tedious. It can take a long time. And because you have a number of permutations, it can be quite complex when you consider the matrix of options available to you. Added up, it's quite labor intensive. So we look for unique method development tools, and SPE automation can be one of those. It offers the flexibility and convenience to establish a series of tests and then walk away. It also gives an objective approach to method development because it treats all the samples the same. There is no scientist bias. There's also the added benefit of giving time for the researcher and scientist to focus on optimization details because the method development part is already being performed on the instrumentation. Based on the results, you can change things. And then obviously keeping track of all of the method development permutations and optimization that you're going to be doing, the ability to print out the documentation from the software is key. Some of the topics we will cover today are method development considerations, such as what is your chemical structure and solubility of the one or multiple compounds you are looking at? What particular SPE sorbent packing will you use, and what weight in the cartridge? And then also, based off of your cartridge, that you determine what is the optimal sample load and concentration. For automation optimization factors, I utilize the Smart Prep Extractor from Horizon Technology, and I looked at Elution solvent for the different compounds. The air vent push and how much of that I would use to push out each of the compounds of interest during elution, during load, during washes, etc. The load volume and concentration, how much is too much? And the ability to elute in the smallest volume possible. And lastly, the SPE flow rates that would be used. Here we have a very basic situation for method development. And keep in mind, this is done for a specific reason, to focus on the process for method development and also the optimization factors to consider. So the basic nature of this exercise is to focus on the actual process and details, not the science. So here the situation is to determine which particular cartridge sorbent load and sorbent material to use. Elute from a mixture, which is black, 3 primary colored fractions from that one beginning solution. And then thirdly, to be able to elute in the smallest volume possible. So here you see we have black food coloring as our solution mixture, and the objective is to separate it out into the smallest volume of yellow, red, and blue. So when we begin our method development process, there are really 4 key scenarios to keep in mind, and this is the order that I typically follow. I first look at the structure and solubility of my compounds. Finding out what their structure and solubility are allows me then to select the SPE sorbent and weight that's appropriate. Once I know that, then I can determine the sample load and concentration to put onto that cartridge to then begin the optimization experiments that I'm going to be running. Determining structure and solubility is important just to determine polarity of each of the compounds. FDNC yellow 5 is a very polar compound, FDNC red 40 semipolar, and FDNC blue 1 nonpolar. And this allows me some opportunity to separate out the compounds in considering the elution solvent and also the packing material that I'd like to use. When selecting the SPE sorbent and weight, I recall the chemical structure and solubility of my compounds, and I had a nonpolar, a semipolar, and a polar compound to consider. A C18 based silica sorbent will really work best for me for this particular situation, just because it has the ideal nature of maintaining the hydrophobic compounds and allowing the others to elute from the packing or sorbent material. So I should be able to achieve some fairly good separation just based on the polarity and using a C18 silica-based sorbent. Now in this particular situation I want some strong colors, and so I'm choosing a 1000 milligram 6 milliliter SPE cartridge. I can load a larger volume of sample and also utilize a higher concentration of that sample to get those strong colors. When determining the sample load and concentration for your selected cartridge and sorbent weight, it's probably best practice to utilize the recommendations from the column manufacturer. We see here the different series of SPE steps that were used in this particular method development situation. 2 condition steps where they recommended 6 milliliters of volume. A load step where 500 microliters was recommended, and then because all 3 of the colors were chosen to be collected, we don't have a wash step, we have 3 elution steps, each recommended for a 6 milliliter volume. When we consider automation of this particular method development situation, we look at the software to be able to help with the different series of SPE steps. And this is what the automation affords a scientist, the ability to fairly easily through icons program the software to do the 2 condition steps, single load, and then 3 elution steps. Following the method development structure and solubility determination, selection of sorbent and weight for the SPE column, and determination of how much to load and what concentration to use, the next logical step is to begin optimization experiments. And you can see the list of experiments might be quite long, but the focuses that I took were really on the ability to elute in the smallest volume possible and to be able to have the strongest colors for each of the 3 compounds. So I looked at elution solvent, then air vent push, load volume versus concentration, elution volume, and finally SPE flow rates. In our first series of optimization experiments, the polarity of each of the solvents is utilized when determining the elution solvent. Experiment number 1 is the starting point for optimization. The polarity of our yellow compound elutes easily with water. Vial number 1 shows that 3 milliliters of water does a very good job of eluting the yellow. However, with vial number 2, using a 50% methanol and water solution, both red and blue are co-eluting. Vial number 3 easily elutes the blue with 100% methanol. Optimizing means looking at how we could further separate red from blue. Vial number 2 shows that red is a little bit more consistently eluted with a 30% methanol and water solution separated from blue. However, we do see some inconsistency visible with vial number 1 showing some red co-eluting with yellow. Experiment 3 takes the red separation one step further. If 30% methanol and water works, would 20% methanol show even better separation of red from blue? And we do see a fairly good optimized set of elution solvents. For yellow, which would be water, for red, which would be 20% methanol and water, and for blue, 100% methanol. In the Smart Prep Extractor software package, the ability to utilize these different ratios of elution solvents was done automatically using the mixing chamber, which is on the instrument itself, and the icon that is add to mixing chamber allows the opportunity to add the different solvents together and do the mixing prior to the elution step. And this is all done within the method automatically, affording the opportunity to have the elution solvents available during the method that you're running without needing to pre-mix these in advance and then sipping them from specific bottles. So with the elution solvent selected and allowing for elution of yellow, red, and blue, the next experiment for optimization was to adjust the air vent push. And you wouldn't think that this would be as big of a deal as it actually is in terms of isolating out the different colors. But here I was more focusing on the isolation of yellow within vial 1 from any red that would also be co-eluting. You can see that in vial 1 there is some breakthrough of red, and this to me indicates the push volume, the air vent push, is too large. So what I did was to further that, I increased the push volume by an additional half a milliliter from the original 1.25 milliliters. And you can see the results are the addition of some red within vial number 1. I then went ahead and decreased the push volume by a half of a milliliter from the original 1.25, and the breakthrough of red into vial 1 is removed. We have a nice solid color of yellow, and when this was repeated a multiple series of times, the consistency was there to elute the yellow. So the takeaway from the air vent push is that because it's the amount of time a solvent is pushed through the cartridge, if you push too long, you may actually have some breakthrough of the next compound from the sorbent into your elution tube. The next experiment for optimization was to take on the load volume versus load concentration. Here it's a fine line depending on how much of the compound can interact and bind with the sorbent packing. Loading less volume obviously is going to lead to less color intensity, but I did want to be able to show any impact with yellow and red eluting, and sometimes a lower concentration can make that more apparent. So with the load volume decrease from 1 milliliter to a half of a milliliter, you can see that in vial number 1 we indeed have some red still mixing with the yellow. So it wasn't just alone the air push volume that was contributing to it, it's also perhaps something else. So just to be able to show an impact of increasing the load volume, here we're actually taking the same concentration, we're diluting the sample 3 times and increasing the load from 1 milliliter to 3 milliliters. So essentially we have 3 times the loading volume, but same concentration. And because there is so much load volume taking place, it's too much for the sorbent to actually retain compound, because you're competing with the volume and the compound, you're going to receive some breakthrough. And because the software allowed us to collect all of the steps, we were able to see that with the load step we are getting the yellow eluting through right away without being retained at all on the sorbent packing. So it's a really good idea to be able to, when you're testing load volume, load concentration, to allow for collection of all of the steps so that you can determine where breakthrough may occur. To show how that is done with the Smart Prep software package, it is a visual color determination for the fractions that are collected, and this is the fraction rack on the Smart Prep extractor, showing that I would then be collecting 4 fraction tubes for each of the elution steps, the load plus all of the 3 elution steps. So with the elution being on the agenda here as an important area to focus on, we wanted to be able to elute the smallest volume possible, and optimization really plays a key role in determining where the elution volume would sit for the volume used versus the recommended volume from the cartridge manufacturer. So one of the thoughts to why I might be getting some red in my yellow tube number 1 here would be that I'm just eluting with too much volume. Perhaps the yellow, when you're eluting with more volume, is taking out some of the red and co-eluting red with the yellow. So to prove that point, I reduced the volume from 3 milliliters of elution solvent, which is water, to 2.5 milliliters. And sure enough, the yellow color is a nice clear yellow color without any red eluting in it. And at this particular point in the series of optimization, the experiment number 8 has optimized the elution volume for the yellow, allowing the yellow to have the correct air push volume, load concentration, and also elution volume. When optimizing for the effect of flow rate, you want to see a dramatic impact to be able to assess whether you have optimized the flow rate for your experiment. Here we have shown the increase effect of 5 milliliters to 10 milliliters per minute for the condition, load, and elute steps. It's pretty evident by looking at the image above for vials 1, 2, and 3 that by increasing or doubling the flow rate, we have significant breakthrough of the sample during all of the SPE steps. Vial 1 shows significant reduction in the concentration of yellow, 2, significant reduction in the concentration of red, and 3, significant reduction in the concentration of blue in comparison with the experiment number 8 that optimized all of the conditions. The takeaway here is that loading faster to speed the SPE process can result in sample loss and breakthrough, because what you do have is less time for the compound to interact with the sorbent to be properly retained. One last change was made to this particular method development situation, and it was to go back to another sorbent, go back to another packing sorbent weight, and to be able to see the impact of an optimized situation with experiment 8, where we had an elution volume of 2.5 mils for yellow, isolated from red, isolated from blue. A polymeric reverse phase cartridge was chosen, 6 mil size, but at half the sorbent weight is what we were using in the optimized experiment 8. Just to see what would happen when we changed the sorbent material and sorbent weight, collected all of the fractions, including the load step, and what we did see was yellow breakthrough that is apparent in tube number 1. In tube number 2, you can see that red is not really retained during the water wash. It starts to come off right away into tube number 2. 3 shows that you have a mixture between both blue and red, and 4 is the remaining blue that would elute with methanol. Basically, there is a difference here in what the weight may be and also the retention of the compounds for the polymeric reverse phase that was chosen. With the optimal elution results showing here, the takeaway is to really think about only changing one parameter at a time to gauge the results. Either change the sorbent material or sorbent weight. And after you get to a point in time where you're at an optimal set of conditions, it's probably not the best practice to consider going back to method development when you have an optimized method. If you do need to do that, you really need to consider going back to method development and kind of reverting back to starting with the optimization all over again if a new sorbent and a new sorbent weight is chosen. So let's look at the summary of the takeaways from this particular method development situation. For best efficiency, probably finish method development prior to starting optimization. When looking at the elution solvent and optimizing it, might be good practice to go one step further to assess the impact and make sure you have the optimal solvent. Keep in mind that the air vent push time does impact elution and breakthrough. Best practice to determine and assess the impact of any breakthrough: collect all of the SPE steps: load, wash, and elute. Saving time on the back end following SPE can be done by eluting with the smallest volume possible. Speeding the SPE load, wash, elution steps may lead to breakthrough and does not necessarily help with the SPE process if you're going to be having breakthrough of compounds, because that does lead to loss. And most of us already know this, but it's a good reminder. Changing one parameter at a time allows for efficient optimization. You're able to take each of the parameters and assess the impact of it on the overall SPE process. In conclusion, the SPE automation of the method development process provides the scientist sufficient time to focus on the details of optimization experiments based on results they get back. It's very convenient and flexible to walk up and set up a series of experiments and walk away knowing that these samples are being handled equally and objectively without any scientist bias. Documentation that's ready to print keeps records clear and precise. In the series of experiments shown today, the Horizon Technology Smart Prep Extractor automation did simplify the optimization process. We were able to show that collecting each of the fraction collection steps did show where breakthrough occurred. The ability to automatically mix solvents during the method instead of prior to shows great efficiency and time savings. In addition to that, being able to select from multiple SPE solvents during a method is very effective, including the ability to automatically dilute the sample and mix the sample prior to loading. And lastly, the flexibility was shown in adjusting flow rates, volumes, and push times. Thank you for taking your time to join me today to talk about SPE automation of method development and optimization. Please visit our website, horizontechinc.com.